Woohoo, we're live. This is Math 60, Intermediate Algebra, and we're going to talk about one of my favorite subjects, complex numbers. Complex numbers came out of the drive for mathematicians who wanted to have a complete system. So a system where all questions had answers, which is really a very satisfying situation. Other sciences don't have the luxury of just creating ideas, but mathematicians can follow patterns and then use those patterns to come up with new ideas, which help us think about numbers in a slightly different way. So, what pushed forward the complex numbers or the imaginary numbers is the question, and there are a lot of versions of it, but basically, if x squared plus 1 equals 0, what is x? Right? This is a very simple equation. X squared plus 1 equals 0. You know, it doesn't, it's really hard to get a quadratic that's simpler than that. So if x squared plus 1 equals 0, it can't be factored. It's the sum of two squares. So what we do instead is we subtract 1 from both sides. And once we subtract 1 from both sides, then we get x squared equals -1. And then the question is, well, what does that mean? Because this would mean x equals the square root of -1, something like that. And up until now, we've said, you know what, we can't have a square root of a negative number. Why is that? Let's review. -1 times -1 is +1. So if we square a negative, we get a positive. There's no way to square something and get a negative. Right? And that's what we're talking about here. These two concepts are related. I want to square something and give me -1, or in other words, I want to look for the principal square root of -1. So this really frustrated mathematicians for a very long time until an Italian mathematician, he's only one mathematician, ignore that he's many. He's so fancy and famous that we'll just call him many mathematicians for the purposes of this lecture, named Girolamo, I believe, Girolamo Cardano, I apologize for mangling the Italian, suggested coming up with a new type of number in the 16th century. And right now, I don't know if you can see on the video, but I've got a cat who's trying to get my attention, and he really, really, really wants to go outside. So let's see if we can continue with this, even though he is whacking the computer with his tail. So we're going to define a new number, and it is the number I. And I was chosen for imaginary. Now, you might have remembered up right now, you might have remembered that we call the main set of numbers we use the set of real numbers. And I don't know if you've ever wondered why we call them real numbers. But now we're going to start talking about what imaginary numbers are. So there are real numbers, and then there are imaginary numbers. Okay, so the new number is called I, and I always curl the bottom of it so that it doesn't look like a little 1. And so just to be clear, I squared is -1. There are no real numbers that will do this for us, right? Because, again, over here, if we square a -1, we still get a +1. So we have invented a new concept, I squared. Well, we didn't. This Dr. Cardano, I don't know if he had a doctorate, but this mathematician in the 16th century, so the 1500s, he was coming up with this. So I didn't come up with it myself. I mean, I helped, but I didn't actually come up with the whole idea. Well, maybe I suggested it over dinner, and he wrote it down, and now he's famous for it. So that's the way it goes, right? So if I squared equals -1, then I squared plus 1, which is then -1 plus 1 equals 0. Okay. And it also means that I becomes radical -1. Now, in some situations, for some people, this is not acceptable. So when I was taught math, I was taught you never write the square root of -1. You're just not allowed to do it. The only thing we were allowed to do was write that I squared equals -1, but we weren't allowed to go to this step. So this is a little bit edgy. It's a new century, you know, it's no longer the 1600s. It is now the, whatever it is, the 2000s. And well, who knows? Maybe you're watching it and it's like at the year 3189. Who knows? You know, whenever this video has lasted to. Right now in the 2000s, it is perfectly legit to write this, although I feel a little bit worried when I do it because, again, I was taught you weren't allowed to do that. However, let's talk about the behavior of I. And in order to do this, I want to talk about the behavior of 1. So let's look at, I'm going to come down here. I'm going to skip all these questions and I'm going to say, okay, the number 1 to the first power is 1. Number 1 to the second power is, you got it, 1. Number 1 to the third power is 1. It never changes, no matter what exponent we add. Number 1 to the 0th power, still 1. It's always going to be 1. Okay, what about -1? Well, -1 to the first power is -1. -1 squared, that's +1. -1 cubed, that's -1. -1 to the fourth, +1. And so now with -1, we toggle back and forth. If we have -1 here and +1 here, we kind of go around in a circle. We go -1, then +1, then -1, then +1, then -1, then +1. With the ones, we just have a spot. We're just at 1. And so you never move from this spot. So with ones, we stand in place. With -1, we bop back and forth. Let's look at what happens to I. So if we have I squared, that's defined to be -1. That just is. Now, I cubed. I don't know what I cubed is. Well, that's a lie. I do, but you don't. And so if all we know is that I squared equals -1, what we do is we say, well, it's I times I squared, right? There are 3 of them. So that's I times -1. And I'm going to call that the opposite of I. Okay, I to the fourth. I can split that up as I squared times I squared, right? There are 4 of them, so I take 2 and 2. That's -1 times -1. Oops, which equals +1. Okay, what's I to the fifth? Well, I to the fifth is I times I to the fourth, right? There are 5 of them, so I can split it up into 1 and then 4. But then from, handy dandy, so I to the fourth equals, so that's I to the fourth equals I times 1, which is I. So 1 has a cycle that always stays on 1. -1 has a cycle that bops back and forth between -1 and 1. And I has a cycle that goes around in a circle. I squared equals -1. I cubed equals the opposite of I. And I to the fourth would equal 1. There are 4 possible places we can be. And the thing is that, well, I go I squared, -1, I cubed, the opposite of I to the fourth is 1. I to the fifth also lives here. I to the sixth lives here. I to the seventh lives here. I to the eighth. I to the ninth. I to the 10th. I to the 11th. I to the 12th, etc., etc. Ooh, some of these aren't visible, sorry. There. I'm always getting excited about math and then going off and doing it by myself. So let me show you again. I squared, I cubed, I to the fourth, I to the fifth, I to the sixth, I to the seventh, I to the eighth, I to the ninth, I to the 10th, I to the 11th, etc. So if I say, what is I to the 11th? I can just count around. I can see it's equal to I to the 7th, which is equal to I cubed, which is equal to the opposite of I. So this is kind of cool. Other numbers, like 2 or 4, real numbers, when you square 2, you go to 4. When you cube it, you go to 8, and suddenly you get really big. You don't cycle back around. But I works a lot like 1 and -1 in that it kind of gets trapped in a little pattern, which is also very cool. Okay, so that's the first thing to know about I. They're very interesting. We don't get to really talk about this much, which is really sad. Um, and if you're curious about this, I would say look up modulo math or just mod. Look that up because that will tell you more. If you're interested about these cyclings, you look for I or imaginary numbers and modulo math or mod. So look that up or ask me. I would love to tell you more in office hours and such. But what we have to focus on, of course, is the mathy math, the math that all the other classes are going to want you to understand and know. So complex numbers are made up of, and the set of complex numbers, I should say, is C like this, complex numbers. In the same way that the real numbers are written with an extra line, C is for the complex numbers. Okay, so the complex numbers are C, and we're going to define a complex number in a very particular way. We're going to say it's going to be a mix. It's going to have a real part and it's going to have an imaginary part. And so this is going to get very formal. And this is not necessarily the way you always deal with complex numbers, but it is a way we deal with complex numbers. So let's look at I. The number I is 0 plus 1I. There's the real part. There's the imaginary part because it's got the I attached. How about the number -3 plus I? Well, that's -3 plus. And then here's the thing. A lot of people would put in the 1, but to be honest, sometimes you can get away with just writing the I. It just depends. Same thing here. I could have written this as 0 plus just I. So whether you include the 1 that's a coefficient or not, it's going to depend on the setting and the people who are asking you. Okay, what about the number 5? The number 5 is 5 plus 0I. In this way, all real numbers are also complex numbers. Isn't that cool? So all real numbers are also complex numbers. So any real number is just going to be that number plus 0 times I. Now, again, why did we pick the name complex? Well, again, I didn't. Okay, yes, I did over dinner. Yet again, I had dinner with a lot of mathematicians in the 15 and 1600s. Yeah, no, the food was not as good as it is now. I really like Three Musketeers bars. I really love them. That was one of the best things about living, 400 years is to make it to the 1900s to get Three Musketeers bars. Love them. But it was pretty cool to be there, and meet all these mathematicians in the 1500s. But back then, the word complex, and still now for mathematicians, the word complex means more than one part. Right there. So we've got the 2 parts. That's all. We've named these numbers the 2-piece numbers, as opposed to number 5 originally was a 1-piece number. Now I hear you asking me silently over everything, well, what about a number like I squared? Because you don't have any I squareds in here. And the answer is, well, remember back there, I squared is -1. So that would be -1 plus 0I. So in one of the weirder situations that we're setting up right now, And again, this stuff is weird. I agree, it's very strange. The number I squared does not have an imaginary part because I squared actually equals -1. So even though we use i's to write it, it turns out it's a real number, which is kind of goofy. And what about a number like I cubed? Well, I'll remind you that was the opposite of I. You can look back on the first page and check. So that's going to be 0. And then see, and here it depends. It's either plus a -1i or it's 0 minus 1i, depending on the person who's asking you and how formal they want it to be. You can write it either way, really. Okay, so let's try a couple more problems. Woohoo. We're going to simplify. Now, this is going to be our transition. So how are we going to see complex numbers? Well, if you see a minus inside a square root, up until now we had said, run away, it's not real. So before, we said not real or undefined. Now, I'm going to say the square root of -4 is 2i. And the I tells us we had a negative inside. Now, how would you check? 2i squared is 4i squared. That's 4 times -1. That's -4. That was what was inside the square root. Okay. Ooh, Trixie, Hobbit Scissor Trixie this morning. Cube root of -8, not imaginary. It's a real number. You can take the cube root of negative numbers, remember? Because -2 cubed, -2 times -2 times -2 equals -8, because 3 is odd. So sometimes we're going to try to trick you. We're not going to succeed, though, because you guys are brilliant. Okay. Ooh, another scary one. Square root of 100 is? You got it, 10. These are not all going to be imaginary. Okay, square root of -100, or the radical -100, or the principal square root of -100. You got it? You got it. 10i. Bam. Okay, we're going to continue 7.7 in the next video, do some more really weird things with complex numbers. Woohoo! Math on.